Okay, illustrative math, unit 3, lesson 19 is called real and non-real solutions. So our goal today is I understand when a quadratic equation has two real solutions, one real solution, or two complex solutions. And also I can write equations that have two real solutions, one real solution, or two complex solutions. Before we get going on this, let's make sure we understand, make sure we remember what a complex number is. A complex number is a real number plus an imaginary number. So a plus bi. Okay, so an example of a complex would be like 3 plus 6i, or like -2 plus square root of 2i, something like that. Those are complex numbers. Real numbers are just regular numbers that you could put on a number line. Real solutions will show up as x-intercepts. So two real solutions means you have two x-intercepts. Okay, and one real solution means you have one x-intercept. If you have two complex solutions, that would mean we have 0 x-intercepts on the graph. Okay. So what do you notice? What do you wonder? Pause the video and try to come up with some stuff. I'm going to just kind of jump right into it here. So here's my function, 2x squared plus 4x. So f of x equals 0 when x equals 0 and -2. So a couple things here. You could plug in 0 here for x, and you're going to get 0. So that'd be f of 0 equals 0. You could plug in -2 for x. Here, I'll erase it. I'll just do it again here. F of -2 would be 2 times -2 squared plus 4 times -2. Let's see here. This gives me 8 minus 8 gives me 0. So we would say f of -2 equals 0. So there's some notice stuff right there. I'd also notice that both of those are our x-intercepts, 0 and -2. I would probably notice that I could maybe solve this by factoring. Maybe if I pull out a 2x and set it equal to 0, I'd get x plus 2. And then if I set each factor equal to 0, I'm going to divide by 2 here and get x equals 0, minus 2 here. Okay, so you get the same values right there. Could go with the quadratic formula also. All kinds of stuff there. Okay. Let's go. I'm going to erase and go on to the next one. So let's see here. Same thing here. G of x equals 0 when x equals -1. So if I plug in -1 here, g of -1, 2 times -1 squared, 4 times -1 plus 2. If I do all that math, type it in my calculator, I should get 0. This would be 2 minus 4 plus 2. Yep. So that means when I plug in -1 for x, I get 0. So that would mean my x-intercept is also at -1 right there. You can kind of see there. It's not marked, but you can tell you're going by ones because you skip every line or every other line. What else? I could factor it, or I could maybe do the quadratic formula, or I could even complete the square if I wanted to. But if I wanted to go quadratic formula, x equals negative. Let me write the quadratic formula here in case you're new. Just kind of jumping in here and don't really know what it is. Okay, so a is the number in front of x squared, b is the number in front of x, and c is the constant. So it all has to be equal to 0. ax squared plus bx plus c. So a is going to be 2, b is 4, c is 2. So negative b plus and minus the square root of 4 squared minus 4 times 2 times 2 all over 2 times 2. So let's see what we get here. We get negative 4 plus or minus the square root of, I think it's 16 minus 16 over 4, which this is 0. Square root of 0 is 0. So it's negative 4 plus and minus 0. I don't need to add 0 and then subtract 0. I just get the same number, so I get one value. Now, what I want you to notice here is, notice that this value under the radical ended up equaling 0, and we only got one solution. Now, if I had done the quadratic formula over here, I would have gotten a positive number under my radical, and I ended up with two solutions, okay? So let's go on to this next one. Again, I could plug in 0. Oh, well, I'd have to plug in these values here for x. That might get a little ugly. I'm probably not going to do that. I'm going to maybe just jump right to the quadratic formula here. So let's see here. I'll leave a little room. So x equals negative b plus or minus the square root of b squared minus 4 times 2 times 4 all over 2 times 2. So you go ahead and you do this and you get negative 4 plus or minus the square root of, it ends up being 16 minus 32 over 4. So that you see here, this number here is going to be negative under your radical. That's what the book wants you to recognize here. When you go get a negative under here, that right there causes us to have these complex solutions, okay? I guess I should have maybe done the quadratic formula over here. I guess I could kind of whip it out real quick. Negative 4 plus or minus square root of b squared minus 4 times a times c is 0, because you could always put a plus 0 here. So that gets rid of this last part. So it's really negative 4 plus or minus the square root of 16 over 4. So you end up eventually getting it down to the 0 and negative 2. But what we want you to see here is when this value is positive, we end up with two solutions. When this value here is 0, because that I didn't write 0, but this would equal 0, right? When that value is 0, we end up with one solution. And when that value is negative, we end up with two complex solutions. So two real, one real, and then this would be two complex, okay? So that's the goal of that warm-up, all right? So I'm going to tie that into the next thing here. If you look at the quadratic formula here, you have this x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And this quantity is what's under the radical. And this determines the number of solutions that we have. If this value here is positive, or if it's greater than 0, you're going to get two different numbers because you're adding a number and then subtracting a number. Kind of like I did over here. I'm adding the square root of 16. I'm adding 4, and then I'm subtracting 4. So that's how I get the two different numbers there. If it's 0, well, when you add 0 and then subtract 0, you get the same number. So you really only get one real solution. And then if it's less than 0, if it's negative, that whole quantity will have complex numbers because the negative under a radical will give us I. Okay, so I would write this down somewhere. This is called the discriminant. This will help you determine how many solutions we have and what type of solutions, whether they're real or complex. All right, so here's some equations. We're going to predict which ones will have real ones and which ones are not. Now we're going to use our discriminant here, b squared minus 4ac, and we're going to kind of use this info on the last slide. So hopefully you wrote that down. So here we go. So A is 1, B is -6, C is 5. So -6 squared minus 4 times 1 times 5. So this ends up being 36 minus 20, which gives me a positive 16. So that's positive, so I'm going to have two real solutions. So I will physically see two x-intercepts on my graph. All right, let's go to the next one. B squared minus 4a 4 times a times c. So what do I get? 36. Let's see here. That's minus 52. So I get negative 16. So since that number is negative, we're going to have no real solutions, too complex. So that I will not actually see x-intercepts on my graph, okay? The next one is going to be positive 6 squared minus 4 times -1 times -9. So what's that give me? 36 minus 36. Yep. So since that equals 0, we're going to have one real solution. So the only way to have a parabola with one real solution would be for the vertex to actually be on the x-axis. And the last one, B is actually 0 here. Okay, A is -1, C is -9 because there's no x term. It's really negative x squared. Really, it's like a -1x squared plus 0x minus 9. So B is 0, 0 squared minus 4 times -1 times -9. That gives me a -36. So that's not going to have any real solution. So I'm going to have two complex. All right. So this one will have two x-intercepts, one x-intercept, and these will have no x-intercepts for the second and fourth one. All right. What advice would you give to someone who is trying to figure out whether quadratic equation has real solutions? I would just say be sure to know the discriminant and what it means. All right. So create three different quadratic equations. At least one should have solutions with an imaginary part. At least one should have solutions with only real parts. Solve your equations, write down your equations and their solutions on the table. Okay, so if I want, let's see here, I want b squared minus 4ac. I want to make sure, I want it to be a negative number. So I want this b squared to be real small. So I'm going to make b equal to 1. So make it a 1x. And then I'm going to make these positive because I want a negative times a positive times positive. So if I have 1 squared minus any number here with a negative times positive, it'll end up being negative. So as long as a is positive, so I'll make a equal to 1. And then I'll make c equal to any positive number. I'll make it 5. All right, there's my equation. So it'd be 1 squared, because b is 1 right here, minus 4 times 1 times 5. That'll give me -19. So I know, there we go, that's going to be with my complex solutions. Obviously, there's all kinds of different answers you could have here. So I'm going to go ahead and I'm going to do that quadratic formula here. So negative b. I guess I kind of already did this. I know it's going to be -19 all over 2 times 1. So it's going to be -1/2 plus or minus, change the negative to an I and write it like that. All right, so let's do another one. We need At least one should have solutions with an imaginary part, and at least one should have solutions with only real parts. So let me erase this. You know, it might be easy if I could just make one that factors x minus 2 times x plus 3. How about that? I know that my solutions, I know I'm going to have two real solutions. It's going to be 2 and negative 3. And then I can just multiply this out. So x times x would be x squared. X times 3 would be 3x. Negative 2 times x is negative 2x. And negative 2 times 3 is negative 6. So that way I know for sure that one's going to have two real solutions because I knew what the solutions were to start. If you want to play around with the discriminant, you could do that, but I'm kind of like in this idea here. Oops, it was plus 3x minus 6. Because now I don't really have to do any work because I already know what the answers are. 2 and negative 3. Maybe do one similar to that for the next one here. Or if you want to use the discriminant, you would just need to have b squared minus 4ac equal to 0 or positive. So I would just say greater than or equal to 0. I'm going to do what I did for the last one. I'm going to say x equals 1 and 5. So I'm going to do x minus 1, x minus 5. If you're having trouble multiplying that out, you can make a box, x minus 1, x minus 5, make your box here. So it looks like that. X times x is x squared. Negative x, negative 5x, positive 5. Combine these two, and I get x squared minus 6x plus 5 equals 0. And since I started working backwards, those would be my solutions. All right. All right, so find an example of a function that has only real zeros. All right, so here was my function, x squared plus 8x minus 1. You take a look here on the graph, and you can clearly see we have two real zeros. What I did to kind of make this up is I said, okay, b squared minus 4ac has to be positive or equal to 0, and that would have real zeros. It just can't be negative, technically. I kind of combined the two. Let me go back here. I kind of combined these two. I said greater than or equal to 0 to make sure it at least only has real solutions. Whoops. So I kind of just played around. I said, okay, I want this number to be big. So I made B8. And I wanted these numbers to be small because I don't want to subtract too much and get it negative. So I just said, there's my answer. There's my graph to prove it. Here's my discriminant for 8 squared minus 4 times 1 times negative 1, which is 8 squared. Oh, this ends up being a plus too. I guess I could have made that 64. So that ends up being positive 68. So I know that I'm going to add the square root of 68 and then subtract the square root of 68 to the rest of the quadratic formula. It'd be like negative 8 here and be 2 on the bottom. But anyways, there you go. Only real solutions. All right, so goal, understand when a quadratic equation has two real solutions, one real solution, or two complex solutions. I can write equations that have two real solutions, one real solution, or two complex solutions. I think we're pretty good shape with that. So the last one here. For our cool down, here's a graph of this function. What could you change about this function in order to make a new function that has non-real zeros? So I need to get this thing to move up here, basically. So negative 6, that's your y-intercept, your c-value. So what if I make it like a really big number? Or you could think of here, b squared minus 4ac. We want it to be less than 0. So right now we got 2 squared minus 4 times 0.5 times, we need this number, negative times a positive times another positive would be negative. So we need to make this number bigger. Maybe make it like 10 or something. See what happens here. So I get 4 minus 20. That gives me a number that's less than 0, negative 16. So and there's many different right answers here. But what I'm going to do here is I'm going to say change C or change C to 10, or if you want to say change the negative 6 to 10, that'd be good. So, all right. Well, thank you for watching, and I hope you enjoyed this video.